Okay, we're continuing on the section about the function as a derivative, and I want to start with this graph. It says, sketching the graph of the derivative. The graph below shows the position s of t measured in feet of an object after t seconds. Use a ruler to answer the following questions. So we need to have a ruler handy, and I just found mine. Yay. Okay, so make sure you got a ruler handy. And then it asks us this question. It says, is this the sine function, and how do you know? All right. Is this the sine function? It is not the sine function. It looks sort of like the sine function, but it is not. It does not have the same symmetry of a sine function. The amplitude of a sine function is 1, and so it would toggle between 1 and -1. If it had a different number in front of it, like, what could it possibly be? It goes as high as, this looks like the high point. Maybe this is at 11. So maybe we'd say the amplitude is 11. Then up here it would hit 11, and then down here it would hit -11, but this is -11 and it's going below that. So it does not have the symmetry. This is not the sine graph. Okay, so let's go on to number 2. Draw a tangent line at t equals to 0.3 and use it to estimate s prime of 0.3. So where is 0.3? This is 0.1, 0.2, 0.3. So this is 0.3. So what I'm going to do is go up to where it is on the function, and I'm going to draw a tangent line right there. So I'm going to take my ruler right here and draw a tangent line at 0.3. So there I did it. Now, I want to try to figure out what the slope of this line is. So an easy way to do that is to try to find 2 places where it goes through maybe a hash mark. So I'm going to pick this point, and then let's see, maybe this point. Okay, so this point has the coordinates, I'll say 0.3, 0.36, okay, x1, y1, okay, and then this point right here is 0.5, 0.5, and it's up here at, it looks like 10. So I could just do my slope formula. M is change in y's. 10 minus 6 is 4 over 0.5 minus 0.3 is 0.2. And 4 divided by 0.2 is going to be, what is that going to be? 4 divided by 0.2 is going to be 20. So I get 20 right here. So the slope of the tangent line is 20. All right. M tangent at x is 0.3. What does that mean? That means that the derivative, which is the slope of the tangent line at 0.3, is equal to 20. All right, that's what that means. 3, draw a tangent line at t is 2 and use it to estimate s prime of 2. We're going to do the same thing. So let's go over here to 2. Here's 2. Here's the point. Let's draw a tangent line right there at 2, just touching the curve at that point. There it is. All right, now let's look at this and let's try to estimate the slope of this line. If I was going to travel from this point to this point, let me just try to travel. I'm going to go down this. I'm at 4. I'm going to go down to 0. So the change in the y is -4. And then I went from 2 to 2.1, 0.2, 0.3 to 0.3. So my slope, the change in y, was -4 over the change in x is positive 0.3. So 0.4, -0.4 divided by 3, I'm sorry, -4 divided by 0.3 gives me -13.3. So about -13.3. Okay. Now, that's what s prime of 2, because we're looking at the tangent. The slope of the tangent line is what a derivative is. So that equals to -13.3. Okay, draw a tangent line at 5.2 and use it to estimate s prime of 5.2. We're doing the same thing. So here's 5.1, 5.2, right here at this point. Let's draw a tangent line there. Let's go here. And let's do this right there. Okay, now, what do we think that this guy is? Here's a point. Let's find another point on this line. Maybe maybe here. Okay, what do we think that is? This is, I'm going to have to go up from here to here. This is 0 to 6. I went up 6. So change in y is 6. And how far did it take me to get over? This is over 1, 2 units. I went over 2 units to the right 0.2. So 6 divided by 0.2 is 30. So S prime of 5.2 is 30. Okay, what is the slope of the tangent line at T is 1? T is 1. It's flat. What is the slope of a flat line? It's 0. And T is 4. Here's 4. Oh, look, it's flat. It's 0 right there. What's special about these points? These are, not only is the slope 0 at those points, but these points are called turning points. They are maxes and min. See, this is a max, and this is a min, and this is where the graph was going up, and now it starts going down, and now it starts going up. So we're about to, I want to write down this information because I have to flip my page over to get to the back of the sheet, unless I have another copy. Do I have another copy? No, I don't. So I'm going to have to flip this over. So did I write these down somewhere? Oh, here, I wrote them down on this sheet, so that's fine. What did I get? Did I get the same values? I said that 0.3, I got 15 there. I got 20 this time. That's okay. 0.3, 20, 2, negative 13.3, 5. I got 20 that time. I got 30 that time. Okay. 1, 0, 4, 0. Okay. What's special about these points? Now, on the back, give the intervals where where S of t is increasing. Okay, so this does not involve a derivative. We're just going to look at this graph, and this is what you learned how to do a long time ago. Just say, oh, look, it's going up. It's going up all the way to this point, and then it's starting to turn. So it's increasing from here to here. So we'll just start at 0. We could go back a little ways. We'll just start. It's increasing from 0 to 1. So it's increasing from, or we could go back to maybe negative 0.5. Negative 0.5 to 1, it's increasing. Then it starts to decrease. And so as it say, oh, where is it decreasing? Let's go ahead and answer this down here. Where is it decreasing? It's from 1, right here. From 1, it's decreasing all the way down to 4. It's decreasing from 1 to 4, okay. And where's it? Then it starts to increase again. So then it's going to increase from 4 to, I don't know, 5.2 or beyond. It says, what is the sign of the derivative over these intervals? Okay, let's see. The sign of the derivative from negative 0.5 to 1, let's see. Positive. It's a positive sloping line. And from 4 to infinity is positive sloping line. So the sign is positive here. Alrighty. Give the intervals over which S of t is decreasing from 1 to 4. But look at the slope of this line. It's a negative sloping line. So we say the slope is decreasing here. This is where the slope is negative. S prime is negative during those regions when it's decreasing. Use the information from above to sketch the graph of the derivative of this function. Use the same scale on the t-axis above, but on the y-axis should be determined by your answers to the questions. Okay, so I have labeled the y-axis negative 20, negative 10, 0, 10, 20. This would be 30. And so what I know is a few points that I can totally talk about. On the front page, and yours might not be a front-back page, but what I gathered here was that they said, what is S prime of t? That is a point. When x is 0.3, we said y was 20 because S prime of t was 20. When t is 2, S prime of 2 was negative 13.3. When t is 5.2, then 20 was what S prime of t was. And then we figured out that when t was 1, it had a flat slope of 0. When t was 4, it also had a flat slope of 0. And so we can begin to graph this with this information. Let's go ahead and put these points on here that we know to be true. This is S of t, not t, and this is t. All right, so let's see what we can get going here. at point 0.3, so it's going to be not perfect, but it'll be ballpark. Let's say this is 0.1, 2, 3, 4, 5. So about 0.1, 0.2, 0.3, we're up here at 20. All right, that's that one. And then at 2, we're down here at negative 13.3. So this is negative 10, negative 12.5, negative 13, maybe right there. All right. At 5.2, oh, 5.2 is like off the scale. I can't really get to that guy. At 1, I'm at 0, and at 4, I'm at 0. And then I know that between negative 0.5 and 1, right, it's going to be positive. It's going to be on this side of the x-axis. And then between 1 and 4, it's going to be down here on this negative down here. So let's do between 1 and 4. Let's do this. Between 1 and 4, it's going to do some, I don't know what all it's going to do, but it's going to kind of do that maybe. It's going to be negative. And then it goes positive. Because we know this was a positive number. It's going to have to get up to 20 somehow. So I don't think it starts to curve off. It's probably still going up. And then we know that it's positive here. So right here, it's coming in from up here, right? It's coming in from up here. That's the graph, the sketch of the graph that I would give the derivative of s.